Hi, I'm Bill Highland from Ghost and Spirit Paranormal. Today I'm going to show you a presentation to help you better understand the electromagnetic spectrum. Before I do this, I would like to talk to you as to why I'm putting these lessons together. Most and foremost is all this garbage floating around on TV with these so-called reality paranormal shows. Now you know what they are, I don't have to tell you what the titles are. One thing you have to keep in mind is that these shows are ratings driven, which means there are exaggerations made, there are unrealistic conclusions made, there are falsities, and sometimes outright fraud. And this is a double-edged sword. These shows do good in that they bring light onto the paranormal research field. But on the other side of that sharp blade is that it's flooding the paranormal community with people that are uneducated and don't understand their equipment and are massive targets for skeptics, and they're shedding bad light into the legitimate research that a lot of us are doing. So that's the reasons why I'm putting these videos together. I hope it's informative. I hope you learn something from it, and I encourage you to take it to your groups, educate yourselves. The most important thing you can do in an investigation is be intelligent and understand your equipment and know how to use it properly. All right, let's get started.
What is the electromagnetic spectrum? Wikipedia defines the electromagnetic spectrum as the range of all possible frequencies of electromagnetic radiation. The electromagnetic spectrum extends from low frequencies used for modern radio communications to gamma radiations at the short wavelength or high frequency end, thereby converting wavelengths from thousands of kilometers wide down to a fraction of the size of an atom. Now here's a graph that I'm going to use. It doesn't represent accurately the spectrum, but it gets the point across. And we'll start at the low energy bands. At the very end of the low frequency bands, we have the TV, radio, basic communications, and radars. Those are our communications bands that we use. Moving up the frequencies, we get into the microwaves. The interesting thing about microwaves is they have the ability to rotate water molecules, which creates heat. Therefore, we can use microwaves to cook our food with. Moving up the spectrum, we get into the infrared range. Now, this is an area that I'll be talking a little bit about later, and it's an area of interest to us. Moving up the frequencies, we get into the visible light spectrum, which is our reds, our oranges, yellows, greens, blues, indigos, and violets. On the other side of the visible light spectrum, we get into the ultraviolet spectrum, which is another area we'll be talking about here in a little bit. Beyond the ultraviolet, we get into the X-rays. X-rays are damaging to tissues, but we can also use them in medical uses and such. And at the very high end of the frequencies, we get into gamma rays and cosmic rays, which are produced from our sun, from distant stars, and from nuclear fission and fusion. So let's talk about wavelengths. What is a wavelength? And the definition of a wavelength is a distance measured in direction of propagation between 2 points of the same phase in consecutive cycles. And in other words, it's the distance between 2 peaks or valleys in a wave. And here's an example of that. Here is a short wavelength in the UV range. The distance between the 2 valleys, or 2 troughs, whatever you want to call them, the distance is 380 nanometers. In the long wavelength, you can see in the IR spectrum, the measurement is 800 nanometers at the bottom of the trough. Now, what are the wavelength ranges? Okay, now here's a chart that loosely represents what the ranges are. Now, first let me explain what a nanometer is. A nanometer is a measurement that we use to measure the wavelengths. And a nanometer is one billionth of a meter. That's billionth with a B. That's an extremely small measurement. Down at the long wavelength ends, or the low energy range, our broadcast bands are anywhere from 1 millimeter to 100,000 kilometers in length. Massive, massive wavelengths. We move up the charts, we get into the microwave ranges. Those go anywhere from 1 millimeter to 1 meter in length. In the IR spectrum, anywhere between 750 nanometers to 1 millimeter in width. Our visible light spectrum, what we can see with our eyes, even though the chart at the bottom says the range is 350 nanometers to 800 nanometers, I did some research, did some verifications, and it's more likely between the 750 nanometers to 390 nanometer range. So the chart's off just a hair. In the ultraviolet spectrum, we go anywhere from 10 nanometers to 390 nanometers. Further up, we go into the higher energies and higher frequencies. We get into the X-rays, which are 0.01 nanometers to 10 nanometers. As far as the very other end of the spectrum, into the gamma and the cosmic rays, anything less than 0.01 nanometers is considered those wavelengths. And just to give you an example of the visible light spectrum and how small it is, if you unrolled a giant roll of masking tape that represented the entire electromagnetic spectrum from New York to Los Angeles, and you were standing in the center of the country somewhere near Lebanon, Kansas, you would see a black section on the masking tape that's about 1.5 inches wide. This section represents the visible light spectrum. Now try to get your head around that. It's an extremely small band. Now, how's this information useful to paranormal investigators? Well, it's important to understand this information because we use equipment that is directly related to it. Our night vision cameras and camcorders. These consist of infrared cameras, ultraviolet cameras, that includes the full spectrum, and for those fortunate among us, the forward-looking infrared or FLIR cameras. Now, here are some examples of some photographs taken with each one of those. Now, here's an infrared photograph taken which is anywhere between the 750 nanometers to 1 millimeter range. Now you notice in this photograph, the thing that's missing obviously is the visible spectrums. So all that's left in this photograph is infrared and maybe a little ultraviolet trickling in there, depending on the camera that you're using. Our next photograph is going to be the UV cameras and camcorders, which can see anywhere in the 10 nanometer range to 390 nanometer range. Now looking at this photograph, it's obvious that the visible spectrum is missing along with the infrared. You would never know that this is a white and yellow flower with green petals in the background. And here at the very end, we're looking at an infrared camera. We use a different measurement to measure the wavelengths, and we use what are called micrometers. And a micrometer is 1/1,000,000th of a meter, instead of a nanometer, which is 1/1,000,000,000th of a meter. And this is a photograph using the infrared photo. Now, a FLIR camera has its obvious differences, and I'll try to give you an explanation. Thermal infrared imagers are detectors and lenses combinations that give us visual representations of infrared energy emitted by objects. Thermal infrared images let you see heat and how it's distributed. The camera detects infrared energy and converts it to an electrical signal, which is then processed to produce the thermal image and perform temperature calculations. Thermal cameras have lenses just like any other camera, but in this case the lens focuses waves from the infrared energy into an infrared sensor array, where thousands of sensors on an array convert the infrared energy into electrical signals, which are then converted to an image or video like you see here.
Okay, thanks for watching this video. If you find it useful, like I said, I encourage you to share it with your friends, with your groups, and I encourage you to take it upon yourself to educate yourself as much as you can on your particular equipment that you're using. Understand it. The most important piece of equipment that you take on an investigation isn't necessarily your video camera or your your voice recorders or any other equipment you have, it's your brain. Be logical, be reasonable, and most of all, be skeptical, and use a process of elimination to eliminate everything before you have what you call evidence. And if it is evidence, you have to do everything you can to eliminate the possibilities that it is anything other than that. In other words, do what you can to debunk what you see. You can take that evidence to other people in the field that may have other views of what you're showing them. But most of all, be smart and be safe. We'll talk to you later.